Okay, so module 3 on inheritance, getting into some deeper object-oriented stuff. It's fun to see. Basic overview of what we're going to get into tonight. These are, some of the review of the object-oriented concepts that we've been introducing over the last couple of classes. Specifically tonight, we'll do more reinforcing on inheritance and polymorphism, as opposed to what we did before, which is just kind of introducing the terminology and the concepts and throwing some stuff on the wall to see what sticks. So tonight we'll talk about actually having a base class and a derived class, and as a result we'll be extending those classes and overriding the behavior in the base class, that sort of thing. I want to talk a little bit about fragility, cohesion, coupling in software, because especially if you're new to object-oriented, it's tempting to just jump in there and create a whole bunch of classes and derive things from each other and override stuff and just go hog wild. And eventually, when you're working in an environment where you have a larger, complicated system, like some financial software, or you're working on a company that has a large commercial website with lots of different moving parts and things, it's easy to make some fundamental architectural mistakes that can cause your code to be fragile, and we'll talk a little bit about what that is. Again, another little detour. I want to talk a little bit about the concept of containment and delegation. This is more of a historical point as it relates to Microsoft's release of object linking and embedding 2, when they came out with their version 2 of that a number of years ago, and how they dealt with publishing frameworks where developers like us were supposed to use these frameworks and build software based onto it, and some of the problems we got into there. Then I want to go over, I mentioned last time that all objects in .NET derive from system.object, so I want to dig into that a little bit deeper and go over what each of the methods in that base class are, what they do, when we might override them, take advantage of them, that sort of thing. When we're talking about inheriting from a base class, constructors need some special attention paid to them, because the way you override and utilize constructors and base and derived classes is slightly different than the way you do general methods and properties and things. I want to talk about what an abstract class is and how that fits in. Interfaces, also another way of abstracting objects. And then extension methods. And that'll sort of put a bow on the topic of inheritance for this chapter in the book, and then we'll go from there. So a base class in object-oriented programming is just a plain old class. We have a number of these concepts in software development, terms we throw out there: client-server, mentor-mentee, class, subclass, parent-child. Like parent-child, take that for example. There's really no difference physiologically between the parent and the child, other than one is derived from the other, right? We're mainly talking about, with the connotation of these terms is meant to imply the relationship between the objects, not any physical difference between the objects. There may be differences, there may be lots of similarities, but that's not what we're referring to when we talk about this base and derived. So you should be able to expect in C# or any object-oriented language that when we're talking about a base class versus a derived class, they're both just classes. We're not learning anything new about the language here, other than how to describe the relationship between the two and what functionally happens when we define that relationship. So system.object again. So here's the simple syntax. Let's say that I have a base class called employee. It's got some properties, it's got some methods, whatever. And then I create a new class called salaried employee. The implication is it's a type of employee, a specialization of the employee class. But this is the syntax that I use to derive a class from another class. You just put a column after the class name. You know, all this stuff we're inserting between the name of the class and the open curly brace, like we normally would create a class. And so when you say the colon, you're going to have another class name here that we're going to say this class is derived from. So now you can use the salaried employee in all respects as if it was also an employee class. So if you're going to declare a variable of type employee, now you can create a variable of type salaried employee, and it will have everything that was public in scope that the employee had, which is pretty neat. We also add this concept of protected. Protected is a way to add methods and properties to an object that people that are consumers of that object can't access, but the code that's in the derived class can access it. So that's why we created a new keyword called protected. So we want a way for the salaried employee to take advantage of any functionality that is defined in employee without exposing it publicly to the outside world, or anybody who creates a variable of type employee. You know, normally we would just think of things in employee being public or private. You know, private is only the internal workings of the object. Now we need this in between where we're opening up access to all derived classes of this class to be able to see those methods and properties without further exposing it to public. So that's what protected is. And I wanted to do a little bit of an example here before I go on. So let's create a new project. C#, Windows, console. Sure, whatever. Okay, so we've got our program here. Let me make that a little bit bigger. And as we know, if we're going to create a class in C#, we've got to create a new file. So I'm going to right click on my project over here and say add class employee. So now I get a new file over here called employee.cs, and I get this class set up here. Create a constructor. I don't know, let's create a, sure, an ID. And okay, so I got a basic, let's do another property. I don't know if you see these things that pop up here, all these little shortcut thingies. These are, what do they call them in Visual Studio? Snippets, I think. But they're little templates that you can use. See, this is what we old people used before AI came along and suggested all of the code that you would ever have to type, is we had these little things called snippets. So if you double click on one, it, so if you hit double tab after creating one, it automatically inserts a property with, okay, the type I want to be string, tab. It changes all the data types in there to string. I want to say get name, because that's what I want the name of this property to be, tab. I don't know why it gave me this dependency object stuff. I must have picked the wrong snippet. But you get the point here. I'm going to do this the traditional way, but it'll just, it's like a shortcut so you don't have to type all that stuff. Yeah, I don't know what this is. But play around with that if you like it. I was just wanting to show you that that exists. Public string name get set. There we go. That's a much cleaner way to do it. Yeah, all of that snippet stuff also came along before they gave us the simple properties like this too. So you could see yourself doing a lot of typing if you're trying to just create some simple code. What's it warning me about? Non-nullable property. Okay, fine. There, now it's gone. Okay, so basic employee is defined as an object that has a name and it has an ID. So conceptually, I've done nothing more than this. So now, if I build that, hopefully no errors. I'm going to quickly go back to my main program and say, let's create a variable of type employee. And my constructor requires an ID, so I'm going to give this employee an ID of 1. Since I didn't put a value for name in the constructor, if I want to set that, I have to say employee.name equals Fred. So nothing revolutionary here. I created a new instance of this class, gave it an ID value of 1 in the constructor call, and gave it a name value of Fred by setting the property. Now I can do whatever I want to with it. Okay, so now we're going to create a derived class. So again, it's another class, so it has to be a separate file. So I'm going to right click, add class. The class name is going to be, say, salaried employee. So I created a salaried employee.cs. I've got this, and here's my class definition, just like before. Except that now I'm going to say colon employee. So now it's derived from employee. So now what's it warning me about? There's no argument given that responds to the required parameter ID of employee int. So since employee only has a constructor, so I've overridden I've added a custom constructor to this class. So now it's going to not expose the default constructor. So if I had not included an employee, like let's say I comment this out, I also have to get rid of this. Now I have no constructor of my own, so it's going to infer that I want the default constructor. So now when I come back over here, that error went away on salaried employee, because now it's okay, because the default constructor on this object is going to, in essence, call the default constructor of the employee object, and everything's good. Both of the default constructors don't take any arguments, so we're all consistent, we're all good. If I go back to this and I put back my custom constructor, I come back over here and I put my ID back in. Now we're all good, except for I'm back to this error. So what I can do is add a constructor here. Now I can do one of two things. I can leave this with no parameters, but then I got to do something. I got to do something to call the base class constructor. Now, we don't say the name of the class, we say base. I want you to call the base class's constructor. And now we're all good again. Now, I probably don't want that. If employee has a constructor, it'd probably be consistent to also have an ID required here, and then I pass that ID into the base class's custom constructor, and again, now we're all good. Does that make sense? Any questions about that? Okay, so if we go back to program, the base class employee still works. But now I can say salary employee equals new salaried employee. And that all works great too. So I've got two different kinds of employees. One's a plain old vanilla employee, one's a salaried employee, and I can keep doing this. Let me do one more so I can illustrate what my point is. Add class, and we'll call this one an hourly. Now, could I derive this from salaried employee? Yeah, you can do it. You can derive from whatever class you want to, but that wouldn't fit my use case here. So I'm going to do the same thing that I did. Base ID. And likewise, I can come over here and say why does this keyboard keep doing this? Okay, so I got 3 employees of 3 different types. One of the things that I wanted to point out is you can always do things like equals salary employee.get type. So an object you can call get type on any object, and it return another object of type, and then you can interrogate it for various things about your class, metadata about your class. So namespace, if you want to know what namespace it's in, this is using what we would call reflection. It's being able to access data about our objects and our class structure. So I could, let's see, well, the one that I wanted to come in here and look at is you can see there's a whole bunch of really interesting things that you can call, properties that you can access. Here we go, base type. So you can say, is this even an employee? Is it an employee of some kind, right? Is employee in the list of base classes for this particular instance of an object? So that could be useful. Like if I'm trying to write code that says, if object is hourly, calculate the pay, right? So I could say if it's of type hourly employee, Weekly pay is and whatever we can figure out how to calculate. We can interrogate its properties. How many hours did you work this week? What's your hourly pay rate, etc. And we could do the calculation. But this is not very elegant. I want to also point out that when we're using this thing called reflection, we're employing a technique called late binding, which means the compiler isn't going to know what to do here until not at compile time, but way later, like when this code is actually being executed. Only then will it be able to know what is the value of class type. Is it of type employee or isn't it? And at that point, it can evaluate it and move on. That's very slow relatively. What we'd really like to do is be able to just say, I want hourly employees pay calculated one way, and I want salaried employee done another way, and I want it to just do it. And so this is not what we would call a good object-oriented way of doing it, is interrogating the data type or the type of the class at runtime. So we'll go back and figure out how to do this in an object-oriented way. So I probably have to define some more variables here. Let's go back to the base class employee and define a property. Let's say a float. What are you doing? Okay, now I have a property called annual pay, but I don't know how to implement that. How do you calculate the annual pay for this person? Well, the way it's defined here in this base class, we would have to set it. We'd have to say, okay, here's my employee, emp.annualPay equals, let's say 20,000. Okay. Fred doesn't make very much. He doesn't date much because he can't afford to take girls out to dinner. Okay, fine. Pretty simple, straightforward, just another property we added to it. But salaried employee, for salaried employee, we know how much the salaried employee makes per month. And what we'd really like to know is how can we tell our code when we call it down here. If you'll bear with me for just a second, I'm going to do something else here. Tricky. One of the cool things about object-oriented programming and base classes and stuff is that, let's say I'm going to create a list. I'm going to create a new collection, and it's going to hold employee objects. So instead of just declaring these variables, I'm going to add each of these new employee objects to that list as I create them. So I'll say employees.add.emp. Same here, employees.add salaried employee. Okay, so now I have, let me get rid of this stuff here because we decided we didn't want to do that. Now I want to basically print the annual pay of each employee. This is also taking advantage of one of those concepts that we've been talking about called polymorphism, which is part of object-oriented programming. I can, each of these objects, as it is specialized, as its specializations are defined in its particular class, it can take many forms. So I have a list of objects, but this list only knows that each one of them is an employee, something derived from employee. But it doesn't care. Each of those individual instances can take different forms based on what specialized class it actually is. So I can say for each employee and employees, write employee.name makes, well, let me do this the right way. I get tired of saying do as I say, not as I do. So let me, employee makes annually, comma, go away, employee. Okay, so the main function here is going to loop through each of the employees that I added to the list, and for each one of them it's going to call the name and the annual pay method and print what it is. Let me see if I can, have I destroyed this enough that I'm missing a close brace somewhere? Oh yeah, I guess I am. Okay, so let me run this and just show you what happens right now with. Okay, so Fred makes $20,000 annually, George doesn't make anything, Curly doesn't make anything. Now, part of that's natural because I didn't set the values to anything, right? I haven't set the annual pay of these other employees before I added them to the list, so let me fix that. Okay, now if I run it, so it has the hard-coded values in there, no surprises there. But what I'd really like to do is specialize these things some. So let me go back to salaried employee. So monthly salary, and we'll assume 12 months out of the year. So instead of setting the annual pay for salaried employee, I want to set the monthly salary to, let's say, $2,500 a month. So now when I run the program again, now we're back to, we don't know how much George makes because we didn't set annual pay, we set monthly pay, and it doesn't know how to calculate annual pay from the monthly pay. So salaried employee is a specialized class. Like if I look at this, if I look at the properties and methods of the salaried employee object, I got monthly salary, name, annual pay, ID. Yeah, so these are all the properties of that object. So I've got all of the properties of the base class employee, plus the ones that I added for salary employee. So I inherited all of the employees stuff. And then I added monthly salary to it. But what I'd really like to do is add a definition in salaried employee that defines the annual pay based on the monthly salary. So I need to somehow override the base class functionality and calculate it differently. That's where we get into the inheritance and being able to override this stuff. So there's a couple of ways to do this, and it can be a little confusing, but you'll see why in a little bit. I'm going to do it the traditional way to start with. So what I'm going to do is come to this annual pay property, and I'm going to change it to virtual. What that says is it is okay for any of my subclasses to provide their own implementation for this method. Now, I've provided an implementation here as the default, but if they don't provide one of their own, use this, and if they provide one of their own, use theirs, is what this is saying. So this is a virtual method, virtual function, virtual property. Okay? Now when I come over here to salaried employee, I'm allowed to override annual pay. It's got some more funky syntax there, but so the default says just call the base class's method of getting this property, but that's not what we want. That's the same as what we already had without overriding it. This is just another way to say do whatever the base class was doing. So I'm going to get rid of that, and I'm going to do it so what I want to do is say return the monthly salary times 12. And I don't want them to call set. I don't want anybody to set the annual pay for a salaried employee. If it's a salaried employee, you have to set the monthly salary, not the annual. Okay? So I'm going to set this to private. What is it complaining about? Oh. Private set. Cannot change access modifier when overriding public inherited member. Well, but I want to. But that's what I want to do. There's supposed to be a way to do this unless they change the language to make that obsolete. So we'll look into that later. But for now, I'll just do it the way they wanted to. So if somebody tries to set the annual pay property, I'm just not going to do anything. I'm providing my own custom implementation of this method, but it does not set anything. It doesn't do anything. So if I go back to here, and I try to set that, it should not do anything. Let's set it to something crazy to see if it sets it or not. Yeah, see, it ignored the 9999. It did not set George's annual salary to 9999. Okay, so I have successfully overridden. See, if I had been able to set this to private, I would have got a compiler error message on this saying, oh, whoa, this is a salaried employee object. You're not allowed to call the set on that object. There's got to be something about, maybe if I say, maybe one of you guys can Google this, how to hide cannot specify access modifiers for both accessors. Yeah, I'm doing something wrong there in the way that I'm trying to do that, because you get what I'm trying to do, right? I'm trying to say it's still okay to get the annual pay because I'm going to provide my own implementation for it, but it's no longer okay to set it because that doesn't make sense for this. But that's how we do it. So now we're saying don't set it, but if you're going to get it, instead of returning the property, just calculate it and return the calculated value. Likewise, we can go to the hourly employee. Let's look at it for a minute. For an hourly employee, we need hours and what their hourly pay is. And so we'll assume like a 2,000 hour year. So I will public override annual pay, and we will return 2,000 times let me make this look a little prettier. $2,000 times hours times hourly pay. So that's how we calculate annual pay for this, and we're going to likewise not provide an implementation for set. There we go. Does that look right? I don't see any issues there. Let me come over to my program. I defined an hourly employee, but instead of setting annual pay, I'm going to set hours equals 8. And hourly pay equals, I don't know, $20 an hour. I don't think I'm calculating that math right. So it's a 2,000 hours per year, but it's 50 weeks a year. Yeah, so 50 times, yeah, we'll make that the weekly hours. How's that? So the weekly hours times 50 times hourly pay. That sounds a little bit better. So this person works let's say a 32-hour week. They get paid $20 an hour. So now we know how to calculate that. So let's see if that works. Yeah, it looks like it did. So now each of those 3 specialized types of objects knows how to calculate its own annual pay based on the properties and values that we set for them for each of the individual objects. And what we're illustrating here is simply creating a base class and a couple of derived classes with specialization overriding functionality in the base class, and then creating objects of those types, setting their properties, and using polymorphism to process them in a generic way, where as we call the annual pay method or property, it actually calls not the one in the employee, right? See, I said in employees, so what type is employee? It's of type capital E employee. It's of type the employee class. But instead of calling the capital E employee dot annual pay property, it's actually calling the one in the derived class. Now I want to contrast that, if that's not already blowing your mind, with another possible way that you might see this. I'm going to take off the virtual from annual pay. Now when I build this, now I get errors. On hourly employee and salaried employee, it says annual pay can't override the inherited because it's not marked virtual, abstract, or override. So if I come back to salaried employee, I've used this override keyword on something in the base class that was not marked virtual. I can still get around that. If I use the new keyword, and heaven forbid they come up with a new keyword, right? Now we've got to have two places and two meanings for the new keyword. But if I use the new keyword instead of the override keyword, that's how you can provide your own custom functionality when the base class did not mark it virtual and did not give you permission to do it. However, it has a nasty side effect. I'm going to go fix this too. Notice when I run it, now I don't know how much George and Curly make anymore. Why is that? What did I lose? It was working so well before. So using the new keyword allowed me to provide a different implementation for the same overloaded name, right? Annual pay is overloaded because it has the same signature as the function in the other classes. So it's overloaded, but it's not being overridden. So what's going on here plumbing wise is this variable employee, lowercase, is of type capital employee. So when it processes each one of these items in the list, each of the three items, even though the actual, if I said get type on that variable, that value in that variable, it would tell me which of the three classes it actually is. It would identify it. However, when I use the name annual pay, when I access that method, that property of this object, it's no longer going to look to see if there's a specialized version of it in the derived class. It says, no, 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 no. That base class did not give you permission. It did not make it virtual. It didn't give you permission to override the behavior defined in the base class. Even though you did, that would create a pretty bad security hole if code across the Windows ecosystem was not written to be virtual, but yet somebody could still come along and subclass that object and override the behavior. You could get in there and do all kinds of nasty, nefarious stuff, and you're forcing all the consumers of that object to accept your new implementation of it, even though the people that wrote that base class had no intention of that functionality ever being overridden. So that's what's going on here. You can do this either way. You can either not mark it virtual and say new in the derived class, or you can say virtual and override in the derived class. And this is the difference between those two ways of doing it. So if I was to say, let's say if employee dot, right, if it's of type employee, then yes, do it this way. Right, I can have a nice little nested if statement. Right, the way where we were talking about it before that we shouldn't do because this isn't the elegant way to do polymorphism, remember? So now I can say, how about salaried employee S equals, and I'll typecast it. So now my variable is actually of that type. So now if I do it this way, I should actually get, yeah, see now it knows how to calculate George. Okay? Does that make sense? And to finish the thought, I guess I could do hourly too. See, now we're back to it's actually calling the specialized version of that function. So we could do it that way. We can still write our code interrogating the actual type of the object, but the protection is still there. You can't do that to this object. You can't replace the behavior in a way that was unintended by the writers of that class. Make sense? Yeah, so another thing we talked about before, the difference between is-a and has-a with the relationship type of thing, the encapsulation versus composition or inheritance versus composition. So the relationship between salaried employee and employee, is that an is-a or a has-a? I would say salaried employee is a employee.
Oh, yeah, because they're already employed, right?
Hourly employee is a employee. Yes. You can't say employee is a salaried employee. No, it doesn't go the other way. And you can say, you know, if I look at employee has a int. It has a string. It has a float. It's composed of those things, but it's not inheriting the functionality of integer, string, or float. See the difference? So hopefully that, yeah, I know we talked about that before, but all this stuff we're talking about in abstract terms, when you actually see some examples of it, hopefully it makes a little bit more sense. Another thing is I want to talk about this notion of being abstract. So all of the examples that I've given you so far, I provided a default implementation of it. But what if I didn't? It might be better to illustrate this with a function, just so I don't get tied up with any weird. How about public bool has vacation? but I'm not going to define an implementation of it. Yeah, let's make it virtual. I don't want to confuse things too much. So yeah, it's virtual. It can be overwritten. I'm giving subclasses permission to override this. And notice it's still red. And if I, see what that is, yeah, it has to declare a body. Why? And that's the tricky part. That's the way I make this work. I have to mark it abstract, extern, or partial in order to not have a body. In order to tell the compiler that I intentionally am leaving off a body because I didn't intend to provide an implementation of this. So if I say virtual abstract, oh, yeah, it's abstract or virtual. Now what? Oh, yeah. So a couple of things happened there. I've created my first abstract method of this class. Now it's going to complain. It's going to say, you got to tell me up here that your class is also abstract now. If a class has one abstract method in it, the whole class is now abstract. What does abstract mean? Simply that you can't create an instance of it anymore. So if I come back over here to program, yeah, see where I say new employee? Now I get this. Sorry, you can't create an instance of the abstract type employee. So that's what happens when we create an abstract class or we provide a method with no implementation in the base class. We're forcing the subclasses now to provide an implementation of it. There is no default that they can inherit. You have to provide an implementation yourself now. Now I could simply say, this is another salaried employee. Of course I have to, let's say 2,800 a month. Oh, EMP. Okay, now we're kind of back. I should get rid of this too. That's not needed. So now I've got two salaried employees and one regular employee, but I'm no longer allowed to create a new instance of an employee object because it's abstract. Okay, so it also means when I come over here, my salaried employee, I now get red squigglies on it too. You put your mouse over the error and as you might expect, it says, hey, salaried employee doesn't have an implementation for that abstract member has vacation. You need to create one. A cool thing about the IDE is I've got this little helper over here. I can just say, implement the abstract class, and boom, it adds the missing one. Now, this is kind of interesting. You can say, okay, I'm going to provide an implementation of it, but later. That way it'll at least compile. And if you ever forget for one of your specialized classes to come back and provide a real implementation, then whenever you accidentally call it, it'll just throw an exception. That's a handy way to do it, and I recommend you take advantage of this pattern because it will save you at some point. If you just had an implementation like this, well, if you did something like this, great. The compiler error goes away, but you could be creating yourself all kinds of logic errors down the road. So that's actually a good pattern. Now in this particular case, I'm going to say the salaried employee does have vacation. And when I come over here to the hourly employee, I'm going to say notice how it added the override. It's a virtual, so, well, it's abstract, which is virtual with no implementation. Virtual is virtual with a default implementation. Abstract is virtual with no implementation. So I'm going to say the hourly employee implements this by just returning false, and the salaried employee implements it by returning true. Let's make this a little bit nicer. We'll say, okay, I think I'm back to, I can get rid of this. I can just say, I don't have to do my fake polymorphism. Okay, we're back to the simple way of processing these. We'll say vacation equals okay. So let me run that. Hopefully there's no other compilers. I lost my annual pay somehow. What happened to my annual pay? Oh, I've still got new. What are we doing here? Employee, annual pay, virtual, okay, it went away. It just took a second. And we'll make this override. Okay, so those are back to the way they were to start with. Can I build it? Yep. Okay, let's run it. Okay, that worked. So I'm calculating the annual pay correctly, right, with those virtual methods, and now I'm getting my vacation in a custom way. And the only difference between annual pay and has vacation is, again, has vacation doesn't have a default implementation, so it's marked abstract. And annual pay does provide a default implementation in the base class, which does us no good anymore because there's no way to actually use it. It's dead code, in other words. But there you go. Any questions about that? I know it's starting to become a lot to throw at you, so I think I beat this example to death. That's about all I wanted to show to you for this. So if there's no other questions, I'll just move on. We good? Okay. All right, little detour here on fragility. So what are we talking about by fragility? The idea that when you're trying to define maintenance of a software system that is growing ever more complex, that you make a small change in one part of the software and inadvertently you cause bugs in another part. So that's what we call fragile. And I've been at companies that have tens to hundreds of thousands of lines of .NET code, and I would describe every one of the systems that I've worked on in that situation as being extremely fragile. It was very hard to find employees that understood the system well enough to confidently make changes in certain areas of the code without inadvertently breaking stuff and requiring lots of software testing, lots of support calls down the road when behaviors changed mysteriously, where we added gremlins to the system. And one of the reasons why there's these metrics that you can think about in terms of software. A couple of them are called coupling and cohesion. Coupling is like whenever you have a function like our main function that is going to create an instance of and call methods in and in other ways use or consume the employee object, then the main function and the employee object are now coupled together. Okay? That's all we're talking about. They're dependent on each other in some way. You know, it may just be one way. It may be, you know, main function is a consumer of the object. The object doesn't care anything about the main function. So it's a one-way dependency there. It could be two ways. You can have objects that depend on one another. So that's what we're talking about with coupling. If you're going to have lots and lots of connections between different parts of the system, you're tightly coupling those pieces of software. The more loosely, like, you know, maybe there's a bunch of private methods and properties of the class that we're making them private for the sole purpose of limiting their exposure outside. That's encouraging more loose coupling. So that's generally a better pattern, as opposed to some people, they create a class and they just by default make everything public. You know, you wouldn't just lay your checkbook out on the front porch of your house so that any of your neighbors can come by and look in at any time they want to. Well, I don't care. There's nothing secret in there. Let them do it. Well, it's not about that. It's, you don't want to create dependencies where there's no need for a dependency. Okay. So efferent cohesion and afferent cohesion, as you can see, one is outgoing and one is incoming. That's all that means. You know, it's a tree of dependencies, and, you know, object A depends on object B depends on object C. So now you've got object B has cohesion in both directions. And I guess the biggest thing I wanted to point out here is just the idea of code fragility, and to, like I said, don't make everything public, don't create dependencies where none are needed, and try to find patterns where you can avoid tight coupling. Additionally, there's a really cool tool out there that not very many people seem to know about called NDepend. It's been out there for 20 years or so, and it works on any .NET code. It's not specific to C#, but anything compiled with the .NET runtime, it can go out there and use reflection to interrogate it. And what it does is it measures your software for cohesion, coupling, and dozens of other metrics. I encourage you, just out of curiosity, to go to the NDepend website and look at all of the metrics that they define, and it will tell you. So computer scientists have thought about these problems. How coupled is coupled enough, and when does it become too much coupling? And they've come up with these rule of thumb values that you can use, and it'll go across your software and measure all of the software and then tell you, hey, here are the trouble spots where coupling exceeds 20% or whatever. But, and like I said, dozens and dozens of other metrics and problems that it can encourage you about your code. When I've been working in at least one of these environments where they had this situation, huge repository of software, thousands to hundreds of thousands of lines of code, and highly fragile, I just bought my own version of NDepend, and it saved my bacon. I didn't have to guess. I didn't have to go into a room and arm wave and try to convince people about what the problem was and what we should be doing to fix it. I could say, look, I've done static analysis on this code. Right there's your problem, and we better start investing in fixing it, because the fragility of the system is going to cause our software maintenance costs to continue to go up and our quality from our customers' points of view to continue to go down. And it was very helpful. It's a scientific way of approaching your tool that can't be, you know, there's no emotion in it. There's no my preference versus your preference. It's very objective. So I wanted to throw that out there, the concept of fragility, and that there is help. And you can learn lots of cool terms if you're trying to impress your fellow developers. Oh yeah, let's talk about coupling and cohesion of this particular software. And they won't know what you're talking about, and you'll sound really smart. Okay, so I'm just going to talk about the terminology, so I'll zip through this really quick because I think I've already beat some of this to death. Yeah, polymorphism, I just showed you examples of it, but it just means that, one object, many forms is what we're talking about there. I showed you an example of using the base keyword. If you're in the derived class and you need to access the behavior of the default or the base class, you can call it directly by just using the base keyword. And the compiler says, oh, even though the signatures of these overloaded methods are the same, you're saying base dot and the name of the method. Oh, you want me to call that one in the base class, not your own that you've provided. So it's very helpful. It's a good way to disambiguate which one you're going to talk about. Okay, I talked about the not marking it as virtual and using the new keyword, and I talked about using the virtual keyword in the base and the override in the subclass, so we've already covered this. And we illustrated the fact that the base class functionality can't be usurped without its permission, without its knowledge. If the base class doesn't mark it as virtual, it's protected. Protected's a bad word because that's overloaded too. But the base class is safe, that its functionality is not going to get undercut by something that the derived class is going to try to do. Okay, another detour here. A little history. So back when I was a young pup, full of ideals and aspirations, Microsoft came out with this thing called object linking and embedding. And they came out with the first version of it. And what it was, a long time ago, we didn't have the ability to copy and paste an Excel spreadsheet into a Word document, or copy and paste a Word document into a cell of an Excel spreadsheet. Didn't exist. Then they created object linking and embedding to allow you to do it, but it was very much like an email attachment, where you could put the little icon of your spreadsheet in the Word document, but when you double clicked on it, it said, okay, let me set Word aside, and it would run Excel and open your document. Okay, so it's just an attachment, a way to switch back and forth from one program to the other. But what they thought would be really cool is if you were looking at your Word document and you had a picture of the spreadsheet there, and if you double click on it, it just puts this funky border around the outside, and you're actually editing your Excel spreadsheet in place. And you type in some new values, and you click outside of that, and it saves the new values as part of the document. Well, what that requires you to do, remember last time we talked about JSON, and we talked about how an object can serialize itself out to a stream of bytes or a stream of text?
Yeah.
Well, imagine that you just kind of copied and pasted that text into the Word document so that when you double clicked on it to activate it, it deserialized that back into an actual object that could be manipulated. That's the essence of object linking and embedding 2, is that they were enabling that to happen. However, and I went to the OLE 2 Developers Conference up in Redmond, and it was very interesting, learned a lot. But basically they were teaching the development community how to use this technology and how to develop custom software. And one of the things that I was doing at the time is that I was at American Airlines writing travel software. And so what I wanted to do, for example, was to have a map object inside a Word document where I could email somebody a Word document that contained their travel itinerary. And if they double clicked on the map, they could interact with it. They could zoom in and zoom out and see where their hotel reservation was, relative to the locations of the map that they were viewing, and then click outside of it again, and it went back to just a static map. So we thought that would be a cool thing to do at the time. So I was there to learn about how to do this. The thing is, when they released this, they introduced a concept called containment and delegation. And it was much like what I had said before about the not marking something virtual and using the new keyword, where what they wanted to do is they wanted to produce their own Word and Excel objects, but they didn't want us to be able to inherit from them and to replace the functionality. They wanted to draw the line and protect that. So they created this thing called delegation. And it meant that it was very much more like the has-a relationship than the is-a relationship. And it was very frustrating. And I think one of the results of them doing this is it really limited the reach of the OLE 2 technology and caused it to not be adopted because it was incredibly complicated to try to do what Microsoft was doing and replicate that with your own commercial software. It was very complicated and error prone. We weren't working with languages that were garbage collected at the time. It was mostly C and C++, and so there were lots of opportunities to crash and leak memory and do all kinds of bad things that you really would rather not be doing. But I think it's really interesting to compare and contrast their approach, because later then they came along with .NET, and when they put out the base class libraries, system.object, and all of the other, list, all of the C++ or C# objects that we have access to both use and to inherit from, we're using the inheritance model. You can actually find out how the list.add method is implemented. You can actually look at the .NET code for how it's implemented, and you could write your own collection in a similar way to use a similar algorithm if you wanted to. It's all exposed. It's much more close to being open source and public and transparent to us, as opposed to the object linking embedding 2 method, which was very much, no, you don't get to play in our sandbox, but if you want to do it kind of like we did, go knock yourself out. So to me, when we're talking about is-a versus has-a, inheritance versus delegation, it's a good, interesting history lesson. And I think as a result too, .NET has been much more widely adopted, emulated, and its reach is far beyond what OLE 2 was ever capable of doing because of its closeness. It's a good study in different ways of modeling your software. Okay, system.object, I wanted to briefly go through this. There are a number of methods in the system.object, and since, like we said, everything that is an object in C# or in .NET is derived from system.object, thereby every object inherits these methods. So every object that you could create has a default toString, but it just returns an empty string. That's the default implementation. Not very useful, but you can override it. And that's why in our classes we say public override toString, because it's a virtual method of the root system.object. Now that all kind of starts to click and make sense, right? How the internals work, right? There's also an equals method. So that way the system built in has a way to compare this object to that object. So my salaried employee to my employee or hourly employee, I can compare those two variables and say, wait, are these the same one? Now the default simply looks at the references, which is essentially the memory address where it's stored in memory. And it says, well, if we have two references to the same memory address, then I'm going to return true, they're equal. Well, wait a minute, I could have created two instances of a salaried object, but use the same name and the same salary. In essence, they're logically the same object, but the default equals implementation is still going to say, no, they're different, they're not equal. Okay, so I can override the dot equals though, and I can say, well, if the name is the same and the salary is the same, it's the same employee. So I can then return true if I can create my own if statement, my own comparisons, and return true and make it smarter depending on what my objects happen to be implemented like. Okay, the next one is finalize. So you get this finalize method, and we talked about the garbage collection a little bit before, and so this is just sort of an extension of that conversation. So if you have resources like file handles and communication ports that are open, things that are not managed, they're not .NET objects, but you're holding onto these resources in your object, then you can override the finalize method, and in that finalize method, go ahead and free up those things. What happens then is when the object is about to be disposed of, the garbage collector will call that finalize and get rid of those things for you. But it's not the best pattern. I'll show you the better pattern here in a minute, but it's there. And then get hash code is another important one to know. It's kind of related to the equals because it essentially, to create a hash of something, let's say you've got this class and it's got a whole bunch of methods and properties in it, and the size of the object could be hundreds of bytes, right? So if you're going to have to compare every byte of those two things to see if it's equal, there's places where you need a hash code that represents it. Think of it like if you've not messed with hashes yet, you'll probably need to learn that concept. I would say the chances are very high that if you go for a job interview for a .NET position, they're going to probably ask you questions about hash codes. Mainly because, let's say you have a phone book. Do you start at the first page looking for the phone number of John Smith and flip pages and flip pages and flip pages until you get to the S's? No. You say, oh, the last name starts with an S, so I'm going to jump about 3/4 of the way through the phone book, and I'm going to open it there, and I'm either going to go forward or backward depending on whether I'm before or after that name that I'm looking for. A hash code works very similarly. It's typically used as a starting point in a large collection of data to start looking for the item that you want. So let's say a simple example would be a hash code for my employee object is the first letter of the last name. Very analogous example. What that's going to do in my hash table is I'm going to have 26 entries, and each one of them is going to have a long collection of actual data objects who all of the items in there, their name all starts with the letter S. So I'm going to ignore everything else in the list. If I'm looking for John Smith, I'm going to go directly to the entry that has the S's, and then I'm going to linearly search through that until I find the one I'm looking for. So that's what hash codes are used for. Places where you want to quickly get close to the object you're looking for. Yeah.
If you create an array, could you use a hash code to look in that array? Okay.
Yeah.
That's
Yeah.
weird.
Yeah, and there are hash-based collections and there are non-hash-based collections. And that's what the interview questions will be typically about. Hey, here's the problem that we've got. Which collection do you think would be best suited for that? And you'll have to say, oh, well, I definitely want to use one that's hash-based, so I'm going to probably start with this one. So that's how that works. And we talked about the get type method, so you can get an object representing the metadata about that object, and its toString method can be used to get the name of the class if you wanted to do a console write line on it or some other way use it, like in an if statement like we did. We talked about equals. Okay, yeah, we talked about the abstract. We had an example of that. So if you have anything in the class that is abstract, the class also has to be marked abstract. And you can't create an instance of it anymore. You must create something that's a concrete or typically one of the derived classes. So we covered that. So interfaces. So an interface is similar to an abstract class, except that it's more abstract. When you're defining an interface, you're basically saying, I don't intend to provide default implementations for anything in this object. the whole thing is abstract. So you can just say, okay, well, it's an interface. Now, typically, you would start the name of that class with a capital I. That way, if people are looking at it, it's just a naming convention. But if people are looking at that name of that class, they realize, oh, this is an interface, which means everything's abstract. So typically, classes we derive from, interfaces we implement, is the terminology we would use. So you would implement the interface, and then you're going to have to, and like I said, the IDE will help you with this. You can right-click on it and say, implement all of the methods that are abstract in this interface, and it'll create stubs that each say, throw a not implemented exception to get you started. Just saves you the typing. The great thing about interfaces, though, is at some point, like way in the past, I used to be able to create a class and inherit from multiple base classes. That used to be a thing. But it's fraught with all kinds of problems, because you know how we talked about the ambiguity where the code needs to decide, wait, am I supposed to call the specialized implementation in the subclass, or am I supposed to call the default implementation in the base class? And we use the base keyword and things like that to disambiguate the intentions. Well, it gets really weird when you have multiple inheritance, because then you can't just say base dot. It's, well, which base? Is it an array of base classes? What syntax would I even use to tell it which one of the base classes? Because what if two of your base classes both implement this method, like toString? Something as simple as toString. If I have a class and it multiply inherits from two different objects, and I call base.toString, which one is it supposed to call? So there's all kinds of weird ambiguous problems that come up, and they didn't want to mess with the syntax of the language to try to figure all that stuff out, given how complicated it is to implement, and B, how seldom it's even used, and C, how it's kind of an anti-pattern. It's really, you're doing it wrong if you are deriving from a whole bunch of classes, because how can you be is a this and is a that? It just doesn't make sense conceptually either. So they just said, okay, we're not going to support it anymore. You can no longer create a class that's derived from two base classes. But what they did do is say, I mean, you can't be derived from zero either, because everything's derived from system.object. So in essence, you're always derived from one object. But they said, well, you can implement as many interfaces as you want to. And that's more like the has-a relationship, right? You have a relationship to those classes that you implement. Okay? So that's very powerful. And we'll see an example of that here in a second. But I want to talk about a couple of other things first. So base constructors, we talked about that with the different use of the default constructor or specialized constructor and how to override that with the base method or the base keyword. But I guess the main thing I want you to get out of this is every time you say, I want to create a new instance of an object, a constructor is going to get called. If for no other reason, you have to have something get called to say, how many bytes is this object? And I got to go allocate the memory underneath it to have the memory for that instance of that object. Then additional stuff can get called to initialize the pieces of that object, but you got to allocate the memory at the very least. So a constructor or multiple constructors will be called every time you create a new instance of an object. You can have multiple constructors, as we've seen before, and which constructor gets called depends on the signature. When you say, I want to create a new object, well, what parameters you pass to it, the signature of that call is going to determine which constructor gets called. Yeah. Destructors. We've talked a lot about constructors, but destructors. So if you create a method with the name of the class, but with the little squiggly in front of it, that's the destructor. You can create a destructor. It's usually not recommended unless you have a really good explicit reason. And you can Google reasons in C# to create a destructor, and you'll get a good description of that. But essentially, it's, do you have any resources that are non-managed? If it's managed resources, if there are other .NET objects that you're composed of, you don't need a destructor because .NET already knows how to handle that. If you provide a destructor in that case, you're just interfering with and making it more clumsy for the garbage collector to know what it is you're trying to tell it to do differently than it's normal. So in that case, don't do it. And in the case where you have non-managed data that you're composed of, that you have a hold of in your object that you're referencing, there's a better pattern than the destructor or even the finalize. It's better to implement the iDisposable interface. So that's 99% of the time, that's what you will see. If your object has responsibility for unmanaged data that is not going to be handled automatically by the garbage collector, then the right way to do this is to have your object implement the iDisposable interface, override the behavior of the dispose method, and in that dispose method, free up those resources. And that way you're sure that it'll get handled automatically by the garbage collector in a friendly way that everybody's happy with and is a good pattern. Additionally, since now you implement iDisposable, let's say somebody has a list of these employee objects sitting around and we're deleting that list. Well, the list goes through there and it says, hey, do you implement iDisposable? And if you do, call dispose. And then that way, when the whole list gets thrown on the garbage collector later, you've already taken care of all of that first up front. And there's really nothing for it to hold on to while it's waiting. You know, you've said, I'm done with all this data. Great, it disposes of itself and goes down to more of a minimum footprint. Then later when the garbage collector runs, then it just frees up the memory and you're done. So that's the right way to do it, is implement the iDispose. And it also happens to be a good example of implementing an interface, and why would you would want to do that. And the last big thing for this chapter was extension methods. Okay, so thinking about I didn't mark my thing virtual to give you permission to override this, and you still want to, okay, we'll give you the new keyword. You can still kind of override it without usurping the base class's responsibility and authority over that base class method. Okay, got it. What if that base class never even anticipated the need for such a method? You want to invent a new method, and you think it's the greatest thing since sliced bread, but the people that wrote the base class, they never even thought about it. It was never even a gleam in the back of their mind. Well, you can extend classes for your own purposes. Now, you know, company ABC in Wyoming that is writing their own .NET program, just because you added an extension method here, it's not going to have any effect on anybody else out in the world that is consuming that class already. But for your program, you can add these extension methods and it'll be like they become part of that base class. So the example that I put up here is for integers. Wouldn't it be nice if you had a good way to just say, hey, is this an even number or an odd number? You just ask the question. You have a method that returns bool is even or bool is odd. That'd be helpful maybe. Or you could extend that further. You could have a method that says, is it a prime number? You know, whatever you want to envision that would be cool to be able to ask about an integer or to do with an integer. So the implementation isn't that hard. But if I implement it this way, typically you would also put this in its own file, its own class, even though it's kind of extra because everything in here is static. So by making a static class like this, all you're doing is basically saying all of these static methods are loosely related to one another. Okay? But then look over here in the main function on the left. I've said value.isEven. Well, wait. Value is an integer, and it didn't have an isEven method. But by defining it this way, static, and I added the keyword this to the argument list. And that's the magic glue that makes this work. It has to be static, and it has to have the this keyword in the argument list. That essentially pretends that it now is part of that, and I can call it using the syntax as if it were. This is also a great way for .NET they can add extension methods without changing the base implementation. You know, you can see this could be very powerful. So, but that's extension methods. It's a great way to extend the features of a class and make it look like it's part of the class, even though the people that actually developed the class had no idea that that would be even a thing that anybody wanted. I like them. I use them frequently when I have a need, and I find them very convenient. So it's good stuff. So to wrap this chapter up, we went through some object-oriented concepts again, peeling the onion back a little bit deeper, going a little bit deeper on inheritance and polymorphism. We talked about, extending and overriding behavior in a base class, fragility, the value of inheritance over this containment delegation method. We talked about system.object and what it contains and why we might want to override the default behavior. The most common one you'll override is toString. I find I override that all the time. Talked about base class constructors, abstract classes versus interfaces, and extension methods. Any questions about any of that stuff? I know it was a little bit of a whirlwind. Okay.